All right, the new stuff for today, graphing rational equations. All right, rational is kind of tricky. Graphing is kind of tricky. Today is longer than most days. But hey, it's a block day, so we got time. We'll have plenty of time to do notes, plenty of time to start the homework. So it's maybe the hardest day of the unit, but we landed it on a block day. So that we'll have time to do it. Thank you. Oh, it's your first one. You'll be fine. So again, today's a little bit trickier than most, but we have some provided notes, some not provided notes, and then we'll work some of the worksheet together. So hopefully, and you got a block day to figure it out, so hopefully it will be okay. Well, let's start with the not provided notes. We'll do a little bit of these for some background kind of information, and then we'll jump to the fill in the blank notes. So Unit 3, this would be Day 4. Rational function graphs. Right, and it's super important that you write it with the correct capitalization so that you approach this with the correct mindset. Right? We're going to have some ratio fun today. Fraction fun. No? No. Well, let's first, big picture, what does a rational function look like before we start graphing it? You've seen them already, like that's what we were working with yesterday or day before. A ratio of polynomials. Some polynomial in the top, some polynomial in the bottom. And maybe the key to the whole thing is understanding the difference between 0 over 4 and 4 over 0. Thank you. Because 0 over 4, what's that equal to? 0. What's 4 divided by 0? Undefined. So if you get those backwards, you're going to mess up everything in this today. But if you know those, keep those straight, you're well on your way to being just fine for what we're going to do today. If you're still struggling with those, okay and no is how some people remember it. If the O is in the top, that's okay, we get a 0. If the O is in the bottom, that's an O, that's undefined. A little side note, if it's 0 over 0, that's, 2 O's. Something, let's get to calculus before we answer that question. That's a calculus issue there. So we won't have that. Well, actually, we kind of have that. We'll talk about it in a minute. Not to the extent we have it in calculus. But again, main thing is, if it's 0 on the top, it makes the whole fraction 0. If it's 0 on the bottom, it doesn't work. If you keep those two straight, you can make sense of most of the rest of what we're going to talk about today. Domain. Domain. Do you remember what variable goes with domain? The x. So the domain we can think of as the allowable x values. And the main thing we're concerned about is that the denominator can't be 0. Now, for each x, that makes denominator equal to 0, either one of two things happening. So if something makes the bottom 0, it's a hole, it could be a hole. That would be where factors cancel. So like if you have x minus 2 over x minus 2 and some other stuff, the x minus 2's cancel, but that means on the graph at 2, whatever's going on there, there's a hole there. So x can't be 2, because that would make the bottom 0, but you kind of cancel it out, so it's not as big a deal, but you still can't have x2, and so what that means is there's a hole. That happens where a factor of the denominator cancels. Or, if it doesn't cancel, that would be the other option. There's a vertical asymptote. So if you have x minus 2 in the bottom, maybe you got more stuff in the bottom, more stuff in the top, but the x minus 2 is stuck there. There's nothing you can do about it. Then at 2, I mean, I don't know what this graph looks like because I don't have any other information, but there's a vertical asymptote if the factor doesn't cancel. When factor of denominator does not cancel. So that's the first chunk of stuff. Domain, denominator can't be 0. When the denominator is 0, it's either a hole or a vertical asymptote, depending on if it cancels or not. Another maybe way to think of it, how to remember it, is if they cancel, that sort of leaves a hole in your equation. Like you canceled both, it makes a hole, and so that puts a hole in the graph. If it doesn't cancel, you're stuck with it, and you're stuck with a vertical asymptote. Let's look at an example. Y equals, let's go ahead and start with the factored form. We do enough factoring. X minus 5 times x plus 3 over x plus 3 times x minus 2. By the way, on these questions, we don't ask many of the questions for graphing because there's like 8 parts to them. The good news is we will always ask the 8 parts like individually. We don't just give you the problem and say, here, graph it. We give you the problem. We ask for the 8 parts individually, and then you graph it based on those 8 parts or 7 parts or whatever it is. But you don't have to memorize what the 8 parts are. You do have to know how to do them, but we'll prompt you for all of them. So that makes it a little bit easier, hopefully. So the first question is always going to be, what's the domain? And for this one, tell me what, well, first of all, for domain, am I looking at the top or the bottom or both? Just the bottom. So I only care about the denominator. So what can't x be? Let's phrase it that way. Can't be negative 3. And it can't be positive 2. So there's 2 things that x can't be, because that would make the bottom 0, and we can't divide by 0. Now we don't know yet if those are holes or vertical asymptotes. We'll look at that next. So the next question will be, are there any holes? Well, do any factors cancel? Yes. So there's a hole at, what's the x coordinate of the hole? Negative 3. But a hole is like it's not a point, it's sort of a non-point, right? It's not there, but it's on the graph. So I want the y-coordinate of the hole. So how do I find the y-coordinate if I know the x-coordinate? Plug it in. I better plug it into the reduced form, though, because what happens if I plug it in before we reduce? You get 0 over 0, which we don't really know what to do with. So after we cancel, then we can plug in -3 to what's left. Let's see, that'd be -8 over -5, 8/5. Thank you. Okay. Julia. So 8/5, that's the y-coordinate of the hole. That would be kind of a pain to graph, but 1 3/5, we could figure that out. So holes are a little different because, do y'all need Julia now? Is that what you? Oh, she's going. Okay. So a hole at -3, 8/5, because that's the factor that canceled. Vertical asymptote. Where is there a vertical asymptote? Go color coordinated here. Well, that would be the one that doesn't cancel. What's the equation of a vertical line look like? X equals something, and in this case, x equals 2. Every issue you list in the domain is either a hole or a vertical asymptote. So we always think of these three things as kind of going together. And we'll always ask them as the first three things we ask, and we always ask them in that order. So you kind of get in the routine of how to find them. Domain, holes, vertical asymptotes. Again, we'll kind of put it all together with a notes page in a minute. So that's the first section of stuff. Domain, holes, vertical asymptotes. Kind of goes together. Next section is horizontal or slant asymptote. The or is pretty important. We'll always ask you for both, but they'll never be both. There's one or the other. And for us, there'll always be one or the other. Horizontal or slant asymptote. There's always one or the other. Like that's as opposed to you could have as many holes as I want to give you to mess with. You could have as many vertical asymptotes as we want to mess with, but you can only have one horizontal or one slant. And for these, we're going to look at the degree of the top versus the degree of the bottom. What's the degree? What does that mean? What'd you say? The highest power of x. So the highest power of x is what will determine whether we have a horizontal or a slant. So there's three different cases you could have for degree of top versus degree of bottom. The top could be bigger, the bottom could be bigger, or they could be the same. And I said that in a different order than I'm going to write, but that's okay. So one option is bigger on the bottom. So an example of that might be 7x plus 14 over x plus 3, x plus 1. Well, what's the degree of the top? 1. X to the first, so degree is 1. Degree of the bottom sometimes throws people off because they're like, well, the highest power of x you wrote down is 1. And that's kind of right. But if we multiplied it out, what's the degree of the bottom? 2. So be careful if it's factored. Be careful if there's a double root, right? Because that would add an extra one or a triple root. So if it's all multiplied out, that degree is 2. Right? Because I'd have x squared. And after that, it doesn't really matter what I have for this part of the problem. And so what we're looking at is when x gets really big, we got an x squared in the bottom and an x in the top. So like they're both getting big, but which one's getting bigger faster? This is a calculus kind of thing. The bottom, because it's x squared. So like they're both getting big, but if the bottom's getting bigger, then you got a big number divided by a really big number. You know what that would be? If you take a big number and you divide it by a super big number, you'd have a small number. In fact, you'd have a really small number that approaches, as in an asymptote, of 0. I left a little blank there because there's a little acronym that goes with this. So if it's bigger on bottom, you get y equals 0. Now, I'm going to teach you the acronym. I'm not usually a fan of acronyms. I'd rather you understand the math. So understanding the math is, as x gets really big, the bottom gets bigger than the top, which means we head to 0. The acronym part is take kind of the first letters, B, O, B, O. Although that second letter is a 0, not an O. Or that second O is 0. Bigger on bottom, 0. So this is the shortcut way to think about it. Bigger on bottom, y equals 0. Well, we could have bigger on top. So we could just reverse those. Yeah, let's just reverse those. X plus 3, x plus 1, over 7x plus 14. Degree 2 over degree 1. Well, as that gets bigger, as x gets bigger, which one gets bigger faster, the top or the bottom? The top. So this is the trickiest situation. This is our least favorite because this leads to a slant asymptote. And for a slant asymptote, we'll have to divide. And usually we can synthetic divide. So bigger on top means slant. So if we take our first letters again, bots, bigger on top, slant. Or bigger on top, synthetic is another way to say it. To get a slant, I guess you could put 2 S's there. Slant or synthetic, or both. But 2 S's, I like 1 S because then it makes me think of like robots. Which is completely unrelated to this problem, so that doesn't really matter, but I usually put 1 S for slant or synthetic or both. All right, the last case is where they're equal. I'm going to give you the acronym and see if you can come up with what you think it stands for. Eats DC. So yes, they're equal. What's equal though? When you say they're equal, because people get stuck on E, they think
equal at top slant. Something else.
E doesn't stand for equal. When you say they're equal, what is equal? That will tell you the E. The degree is equal, but another word for degree that starts with an E, exponents are the same. That's the E part. Exponents are the same. Figure out the DC here in a minute. So let's say we have y equals 8x squared plus 12x minus 7 over 4x squared minus 9. Well, as x gets really big, so thinking about as x gets big, again, the only terms that matter when x is really big are the lead terms, right? If x is a million, then who cares about 12 million minus 7? And really, who cares about 9? If we're doing 8 times a million squared, like the lead terms are really the only ones that matter. So this sort of equals, right? I can't put exactly equals because it doesn't exactly equal this, but it sort of equals, at least when x is really big, 8x squared over 4x squared. But then what does 8x squared over 4x squared equal? 2. So now you might be able to figure out what DC stands for. You got the eats part, exponents are the same. Double crossed. Not double crossed. Degree constant. Now what did I do in order to get my answer of 2? I divided the coefficients. Now again, be careful, you can't do that unless its exponents are the same. But if exponents are the same, then you can divide the coefficients and get y equals 2 for your horizontal asymptote. Well, let's back up a second. So y equals 0, that would be horizontal. Y equals 2, that would be horizontal. Obviously a slant would not be horizontal, it would be slanted. So, horizontal versus slant asymptote, Bobobot eats DC. Bigger on bottom 0, bigger on top slant, which means synthetic divide, which means a lot of work. Exponents are the same, divide the coefficients. So we like A and C. We like Bobo and eats DC. Those are the easy ones because there's really not much work. I guess Bobo would be our favorite because there's no work. Eats DC, pretty minimal work. Slant, we'll have to do one of those later because that's a lot of work.
So if we get an equation is A, then the answer is just y equals 0?
Yes. If you get an equation that looks like A, we ask for the horizontal or slant asymptote, it's y equals 0. You don't have to do anything. That's why we like that case, because the answer is 0. Nothing to do. Case C is not that much harder. If the exponents are the same, divide the coefficients, you're done. It's that middle case that you got to go off to the side and work a whole synthetic divide problem. Right now we're just trying to get the overview, so we're going to not do a synthetic divide problem yet. We'll come back to that later. All right, we're on the downhill run for the non-provided notes. Third set of things we'll ask for is intercepts. This is supposed to be old news, but we'll see. Do you remember how to find a Y-intercept? Let's look at a picture. there's the Y-intercept. Which coordinate do I know for that point? 0 for x. I don't really know y. So we'll set x equal to 0, and that will tell us the Y-intercept. For X-intercepts, I guess I should note that it could be plural, so we could have more than one. If a point is sitting on the x-axis, which coordinate do we know? And what is y? 0. So we'll set y equal to 0. And then lastly, Roman numeral 4. Basically graph everything you know. And if you need to, use a table of values for more points if needed. If needed, because sometimes you have a ton of stuff. Like you've got a couple of holes, you got a couple of vertical asymptotes, you got a horizontal asymptote, you got a Y-intercept, maybe you got 2 X-intercepts. If you have all of that, that's probably enough to know what the graph looks like. Sometimes you don't have much information. Maybe there aren't any intercepts because the asymptotes land there. And so there's not really enough to go on. If that's the case, then you can just plot more points. I mean, you can always plot more points. So if you graph what you know and it's feel like I don't know enough, well then pick some more points, make a table of values, and plot however many points you need to figure out what the graph looks like. Let's apply all that stuff we talked about and do some example problems with it. So example 1, find the domain of f. Well, I think there's probably something we should do first with number 1 before we find its domain.
Wait. You simplify. That's not your pet.
Not factor. So let's factor the top and factor the bottom. So x plus 1, x plus 2 in the top, x minus 2, x plus 2 in the bottom. Find the domain of f. So that's things that x can't be, and we're looking in the denominator. So x can't be plus or minus 2. Occasionally we'll ask you to write that in interval notation. So that would be negative infinity to negative 2, negative 2 to 2, 2 to infinity. But I would only do interval notation if it specifically asks for that. The easier way to say it is just x can't be 2 or negative 2, because that'd make the bottom 0.
How do you know it's not like brackets on the
Really good question. How do we know it's not brackets? What does brackets mean?
like it's included?
Right, and we specifically said
Oh.
don't include it.
Okay.
So it's a good question, but the whole point was we don't want to include 2 and negative 2. So we're writing this all out, all to say don't include negative 2, don't include 2. Part B. Oh, just put somebody's name on film. Part B. Does the graph of f have any holes? The x plus 2's cancel, so there's a hole at negative 2 comma something. So how do I find the something? Plug in negative 2 into what's left. So negative 2 plus 1 over negative 2 minus 2 would be negative 1 over negative 4. So 1/4. So yes, it has holes. You know what? Maybe I should have, on this first one, I'm going to put like really short notes right next to each thing. So like recap notes. Find the domain. That means the denominator can't be 0. Wholes, that's factors that cancel. So this is like super brief recap notes on the page here. Does the graph have any vertical asymptotes? Maybe calling somebody again.
Well, it's x minus 2.
Yeah, x minus 2 is the factor that doesn't cancel. So what is the... Yeah, x equals 2. So again, those first three things always go together. Domain, anything in the bottom that you can't have, is either a whole or a vertical asymptote. Part D and Part E, does the graph have any horizontal or horizontal or slant asymptote? But those questions kind of go together. Right, because it always has one or the other, never both. And so this is the Bobo Bots Eats DC question. Or questions, I guess, because there's two questions, even though there's only one answer. So the question is, what case is this? Is this a Bobo case, a Bots case, or an Eats DC case?
100% Bobo. Yeah,
Well, what's the degree of the top? Well, okay, I should be careful. You can use either one. You can reduce the reduced form. The degree of the top is 1. What's the degree of the bottom? 1. So would you like to revisit whether this is Bobo, Bots, or Eats DC? Bigger on bottom, bigger on top. Exponents are the same. It's an Eats DC problem. So it's not a slant, because Bots is the only slant. But this is not Bots. Eats DC gives us a horizontal. So if I divide the coefficients, and again, I can do this on the original or I can do it on the reduced. Either way. If I divide the lead coefficients, what do I get? 1. So there's a horizontal asymptote at 1. Part F. What is the Y-intercept of F? Well, Y-intercept means set x equal to 0. Again, I'm doing abbreviated notes as we go here. So 0, comma. You can use either the original or the factored or the reduced, but you should always use the reduced probably because it's easier to deal with. So x plus 1 over x minus 2. But if we evaluate that at 0, we get negative 1/2. Right, 1 over negative 2. For the X-Intercepts, and this is kind of nice, there's an S in parentheses sort of indicating there might be more than one. We'll set y equal to 0. So 0 equals x plus 1 over x minus 2. Here we go with zeros and fractions again. What makes a fraction equal to 0? The top being 0 or the bottom being 0? The top. So I don't really care about the x minus 2. Took care of that earlier. So I really only care about the top being 0, because that's the only thing that will make the fraction 0. So x equals negative 1, but I want this as a point, so negative 1, 0. All right, for the graph, use A through G, so use all of our information, and let's see what we've learned. So part A, find the domain. Okay, x can't be -2 or 2. That doesn't really go on the graph. So I can't really use A. Part B, we know there's a hole at -2, 1/4. So I'll put a hole at -2, 1/4. Part C, vertical asymptote at x equals 2. So there's my vertical asymptote at x equals 2. Part D, horizontal asymptote at y equals 1. So there's my horizontal asymptote at y equals 1. Y-intercept at, oh, I guess I skipped the slant, but there wasn't any slants because there's always a slant or a horizontal, not both. So no slants. Y-intercept at 0, -1/2. Part G and X-intercept at -1, 0. Alright, I'm going to say on the left-hand branch of this graph, I know exactly what it looks like because I got 3 points. Plus I have some asymptotes. Graphs get closer to the asymptote. So even though this is our first one, you could probably guess what this looks like. Something like that. But I need to know what's going on the other side, so I need an extra point. Yeah, reverse them is kind of tricky.
Use that as the
Yeah, sometimes that works, sometimes that doesn't. So let's not do that. It's a good idea, and sometimes it does work, like sort of rotated around the intersection of the asymptotes. Let's just plug in a point over there. Primarily because that doesn't always work. It's nice when it works, but it doesn't always work. So I need a point over on that side of the graph. So what's an x value over there? 4. I'm going to pick, 4 is fine. Usually the closer you are to the asymptote, the more likely you are to get a nice answer. So 3 is probably the better choice. Let's plug in 3. Of course, now I may not get a nice answer, but usually the closer to the asymptote, the nicer the answer. So 3 plus 1 over 3 minus 2, because I'm plugging it in. So that's 4 over 1. Nope. 3 plus 1 over 3 minus 2. So at 3, 1, 2, 3, 4. For my purposes, I need to see at least 1 point per branch. If you're not convinced of what this graph looks like, you're welcome to you're welcome to plug in 4 and 5 and 6 and 7 if you really want to trace the whole thing out. If you feel like, it probably looks something like the other side, just sort of reversed, you would be right. So I have to have 1 point per branch. If you want more than 1 point per branch to make sure your graph looks right, you're welcome to it, but all I need is 1. Questions? Again, the questions will always look like this. We walk you through all the pieces, and then you put all the pieces on the graph. Number 2. What do we do first?
You got the factor.
Factor it. So factor that. So there's the factors. It's tempting to cancel them. I wouldn't cancel them until you take care of the holes. Because if you mark them out, sometimes you forget about them and then you miss the holes question. So yes, it's just begging to be canceled, but don't do it until it prompts for it, basically. Domain, holes, vertical asymptotes. Let's pick out some people to do that for us. Once you cancel out, you can use the reduced thing for everything else. It makes life a little easier if there's a hole, account for the hole, and then use the reduced thing for everything else. I'm kind of stuck here. I need a y value for the hole. What do I do to get that? Yeah, plug in -2. So -8 over -7, 8/7, which brings up a good point on these. It's rare that we can write a problem where everything works out to be a nice integer on these. It's just too hard. There's just too much going on. So most of the time your problems are rigged to give you nice answers. And we do that a little bit, but we can't force everything to be nice. So we'll have to figure out 8/7 here in a minute. Ty, how about vertical asymptotes? Good. X equals 5. Side note, some people will put this stuff on the graph as they get it, which is fine. Other people will work all the way through and then put all of it on the graph at once. That's usually how I do it. But if you want to put it on as you find it, sometimes you can catch mistakes if you do that. Like if something doesn't look right, you might notice it, but we'd get there eventually. Right, horizontal versus slant. So that's, well, horizontal is Bobo. Slant is bots. Horizontal is eats DC. So which one is this? Is this a Bobo, a bots, or an eats DC? It's an eats DC. And what do we get when we DC? 4. And you can see that on the reduced form or on the original form. Either way, we get 4. And so there aren't any slants. Y-Intercept will plug in 0 for X. X-Intercept will plug in 0 for Y. So the only thing that would make a fraction 0 is if the top is 0. So if it's 0, 0, that seems a little bit weird, but 0, 0 is an X-intercept and a Y-intercept, so this is kind of a special case here. All right, we've got all our information. Let's put it all on the graph and see that it makes, hope that it makes sense. 8/7. How do I find 8/7 on the graph? Yeah, 1 1/7. So as best you can, obviously how does 1/7 look a whole lot different than 2/7? As best you can, 1 1/7. Vertical asymptote at x equals 5. 1, 2, 3, 4, 5. I usually use highlighters for my asymptotes, but you don't have to. Horizontal asymptote at y equals 4. The trouble with highlighters, of course, is if you make a mistake, you can't undo it. So that would be the danger. And a y-intercept of 0, 0 and an x-intercept of 0, 0. All right, I feel pretty good about the left-hand side. There's only 2 points, but we kind of know what's going on because we have the asymptotes there. So we'll freehand that in. Again, if the freehanding it in bothers you, then pick some more points to get it more precise. Most of you are going to be like, no, I got it. I know the general shape, and that's okay. Now, I do need another point on the other side. So what value of x would be a good pick over here? 6. I mean, not wrong, but that's way way up off the page. So, what's that?
It's there, you just can't see it.
10? I mean, it's not wrong, it's just, Let's try 10. Maybe that works better. 40 over 5 is 8. Oh, that worked out. I like that one better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma 8. So yeah, this thing is sort of barely catching the top corner of the graph there.
So that would be in case it doesn't work off the bat.
I mean, 624 is still on the graph, but you're right, it's way, way up there. All right, for number 3, I'm going to press pause. You see how far you can take it on your own. When you get to the last one there, what makes a fraction equal to 0? The top, so I don't care about the x minus 3. How about this? When is 0 equal to 2? No, that doesn't work. So there aren't any x-intercepts. This would be a case of if you had graphed things as you went, you might know that because there's a horizontal asymptote at y equals 0. So they're not an x-intercept because there's a horizontal asymptote there. Let's see, -2, -2/5. Again, can't make everything come out nice and neat on these. So I'm just trying to put all my stuff on there. Got the whole vertical asymptote, horizontal asymptote, y-intercept at 0, -2/3. I think I got enough for the left-hand side. Again, if you don't like it, if you're like, those 2 points are close together, I want to know what's happening at x equals 2. You could do that. It wouldn't be hard. Plug in 2, you get 2 over -1, 2, -2. So maybe an extra point to help you if you wanted it. That point was not necessary. What is necessary is a point on the other side. So what would be an x value of something over there?
3, 4.
Yeah, the asymptote was at 3, so let's try 4. 2 over 4 minus 3, 2 over 1, is 2, so 4, 2. And again, this is only our third graph that we've done, so we don't know exactly what it looks like, but we've done enough already to know that it looks basically like that. If that bothers you and you want to plug in x equals 5 and 6 and 7 and 8 and 9 and 10, knock yourself out, but save that for the end of the test so you don't spend all your time plugging in points that you don't really need. All right, we haven't done any slants yet, so 4 and 5. We may not get to 6, and that's okay. Number 4, find the slant asymptote. Well, first, how do we know this thing had a slant asymptote?
Because it's literally
Well, it says it.
the way we can do it.
It's bigger on top. This is a bot's problem. Is it eligible for synthetic division? Yes. It's going to have to be because you're not going to do the other one, huh? Oh, we're missing a term, so be careful. I don't know if that was intentional or not, but it's missing a term. So there's our coefficients. What number do we divide with if we're dividing by x minus 2? 2. So copy down the 1, multiply, add, multiply, add, multiply, add. Let's see, we started with an x cubed. We divided by an x. X squared, 2x plus 3. What's that 1? It's the remainder.
Over X minus 2.
Well, the remainder doesn't matter for a slant. You can kind of just throw it away. Now, if you got 0 there, you'd think something was up, because that would mean it was a factor. But if we did everything right, then we shouldn't get 0 there. So our slant asymptote, this is kind of weird. A slant asymptote is like a parabolic asymptote, which would not really be fun to graph, because then you'd have to graph the parabola and use it as an asymptote. You're not going to have to do that. The graph would be approaching the parabola, but we're not going to do one of those in terms of graphing it. Number 5, find the slant asymptote. How do I know this one's a slant asymptote? Well, same reason we knew 4 was a slant. It's a Bot's problem.
So we're never going to be asked to, so like none of the graphing questions will ever be a slant asymptote?
There'll be a slant asymptote, but there won't be a parabolic slant asymptote. There'll be a line. Is this guy eligible for synthetic? I don't like it, but no, it's not eligible, so
It'd be ineligible.
it's ineligible.
So it can't.
Report cards came out, and he is ineligible. So sad.
If this was sports, we can't do it.
So good old long division, 4th grade style. So what times x squared gets me to x cubed? And then we multiply it back, so x cubed minus 2x. Make sure you keep everything nice and neat in the columns. And then we subtract all of that, so we change the signs. X minus 6. What times x squared would get me to x? Yeah, this is the remainder. And we don't care about the remainder. So it's just y equals x is our slant asymptote.
Half x.
It would be like 1 over x.
Square root of x.
1 over x. But then that's what the remainder is, 1 over. But we don't need the remainder, so just y equals x is our slant asymptote.
What does it say up there behind where the camera is?
Oh, behind my face there? The remainder doesn't matter for slant. When you get to the remainder, discard. You don't need it. Throw it out. All right, let's see if we can quickly go through number 6 here, because it's going to have a slant. First thing, though, is change that to minus 20. Or else it won't work right. It won't work at all. All right, so we factor it. We're going to race through this one in the interest of time. Yeah, but we're good at this now. What's the domain of that thing?
Not 4.
Not 4. Yep. Not 4.
No.
No holes. Nothing canceled. Vertical asymptotes. Careful, don't just say 4. I'm glad you did that.
X.
You have to say x equals 4. Because 4 is just a number. A vertical asymptote, you would need x equals on that.
Would it be y equals 4?
Is this Bobo or Bots or Eats DC? Bots, because we just got doing some slant examples. So I need to divide at least I'm eligible for synthetic division here.
Good morning, Kingwood. Sanjay and Carolyn. Please stand for the pledge. I pledge allegiance to the flag
Of the United States of America,
and
to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And now for the Texas pledge. Honor the Texas flag. I pledge allegiance to the Texas, one state under God, one and indivisible. Thank you. Please be seated for the moment of silence.
Support by grade. Check your grades page on the KHS website under activities. The homecoming dance is Saturday, October 23rd from 8 to 10 p.m. and is open to all grades. If you're bringing a date from outside the KHS, see the form on your grade website. tickets for Saturday's game will also be sold off this 1023 on Friday.
So the Slant Asymptote is what makes this one different.
MCA is not just for athletes. We love to see the line we're all about. Freshmen, did you order a class shirt? If so, you need to pick it up from room 4206. Seniors, you can now order class shirts on RevTrack for $15. Orders close on October 1st at midnight, so get them before they're gone.
Good morning, Mustang. This is Mr. Knight, one of your student council sponsors. You may have seen the video the students put out about helping Upper Dublin, Pennsylvania. Kingwood has always been a community that helps others. During Hurricane Harvey, we learned what it's like to have others help us. The small town of Upper Dublin, one elementary, one middle, and one high school, raised $5,000 to send to us. A town of businesses they've never heard of. Now's our chance to repay that favor. Hurricane Ida